All right, it's 12 o'clock. It's 12 o'clock on Wednesday. Times for the Iowa Learning Farms webinar. And hopefully, many of you have been on the last couple days for the Midwest Cover Crops Council webinar. So we've been with the Learning Farms. It's really been great to partner with the Midwest Cover Crops Council on a week-long webinar series on cover crops. I'm Matt Helmers with Iowa State University and director of the Iowa Nutrient Research Center and faculty affiliate with Iowa Learning Farms program. And we're really fortunate today to have Dr. Aaron Daigh. Dr. Daigh is an associate professor at the University of Nebraska-Lincoln. He's a graduate of Iowa State University, and I had the great pleasure to get to work with Aaron a fair bit when he was here at Iowa State and look back on that time very, very fondly. So we are all in for a treat to hear from Aaron today. And he's going to talk to us today about from roots to roots, strategies to protect and rebuild compacted soils. As always, if you have questions, please type those into the chat box and we'll get those to Aaron at the end of his talk. With that, the virtual floor is all yours, Aaron.
All right. Well, thank you very much, Matt. I appreciate the opportunity to be here with you today and to talk about this topic. When we started discussing, options on what could be talked about, one of the things I noticed that in the program in the past is that a lot of cool things have been talked about, but compaction hadn't been. So I thought today this would be a great opportunity to start talking about compaction and how, particularly wheel traffic compaction, and how that impacts our agricultural fields and some thoughts and considerations for folks to take away. So we will get started here. So from ruts to roots, strategies to protect and rebuild compacted soils. Obviously, I'm going to be talking a little bit about roots today, since they certainly play a role in it. Compaction prevents them, but then also they can help bring compacted soils back out and into a more suitable environment. And let's keep moving here. So a few types of compaction just to start off with. Wheel traffic compaction. That's what we're going to focus on today because it's probably some of the most severe compaction that occurs, and it tends to be quite persistent. There's also tillage pans that occur, and those happen just right below the tillage depth where below where the soil is being tilled at, because a lot of these implements, when they push forward and need to break through the soil, they have to exert a down pressure as well. So you can get a tendency of compacting soil just below the depth of tillage. And then we have surface crusting. So we've got these different types of compaction that can occur and emerge as we go about field operations in croplands. But there's another type of compaction that I also want to mention here. We usually don't think about root-induced compaction, but it's essentially also happening out there. But it's very different than what we consider as equipment-induced compaction. And so if you think about a root, inside the soil, it grows, it elongates, and it pushes up against the minerals next to it. And as it pushes, those minerals get shoved into the minerals right next to them. And as the root systems develop and emerge over time, you end up seeing more of this molding of the soil into these pea gravel size clumps that are compacted. And those roots have molded their environment into a way that is very conducive for their overall health and productivity. That tends to be quite different once we get into the level of tillage and wheel traffic and other things that are going across the field, and we end up taking these root-induced compaction molded soils into a much larger scale of compaction where it's long strips, it's deep, it's more uniform compaction, and that tends to be driven away from what the environment that roots really thrive in and like. Now, I want to show this picture right here just to give a little bit of context too. This was a nice study that came out in 2016 out of Iowa State when I was there as well, right before I got done working with Matt on some projects. And the thing is that soil cores were taken about 50 years apart and characterized for different properties. But what I want you to notice is that on these soils back from the 1950s, you see this honeycomb pattern up at the top, and this is describing how deep you get this granular soil structure that emerges from roots molding that soil and into a physical environment that's conducive to them. But then you jump 50 years forward into 2007, and it's much thinner. You don't see it nearly as prevalent. So we're going from soils that are well aggregated and molded by these roots. We have occurrences where wheel traffic compaction can happen. You have to smooth that out, fill in those ruts, prepare a seed bed, and do that over and over. And these soils end up transforming into this more almost massive structure where the compaction is just at a very different scale than what it is that what the roots create themselves. And this is particularly important. I'll just give this a little anecdote here or example, this analogy. I'm a soil physicist and hydrologist, so water flow is one of the big things that I pay attention to in items. But you can kind of look at this in comparison to the roadway system, the highway systems here in the U.S. Highways, they have so many miles, but among all the public roads, it only accounts for really about a little over 1% of all the public miles that are out there. And so if we think about, though, it's only 1% of the total roads. If you look at the percentage of vehicle miles on any given day that's across the United States, it actually accounts for 24% of all the miles traveled. So that small amount, small proportion of roads contributes to a lot of the activity. You think about in soils and you look at like a CT scan here, like what a doctor does, where they try to look inside you without taking you apart. When we look inside the soil, these white areas, you can see these are macropores. These are root channels, earthworm tunnels, things like that. The black area around is where the minerals or more massive chunks of soil are at. And these macropores that you see in white, they typically consist of less than 1% of all the soil pores that exist. But yet, during infiltration events, after rainfall or irrigation or such, they can contribute up to 70% of all the water movement that occurs in that infiltration event. So they're very influential, even though there's a small amount of pores. So a little bit of compaction that takes away these pores, you start changing the hydraulics of how your soils are behaving and how those hydraulics and states then impact your subsequent operations in the field. And so when we think about wheel traffic going across, this is a classic image in a lot of textbooks here that you can see, but we think about different wheel loads that are put down on the ground. They exert some pressure, some stress down into the soil here. And if we look at the bulk density as a metric of how compacted that soil is, 1.3, let's say that would be not too compacted, 1.9, certainly compacted and influencing root growth there. And then we go down into the soil depth from the surface here. These black dots right here would be the bulk density after traffic, but before any plowing that's done in it. So you see this wheel traffic right here down to about 80 kilopascals, and this is about equivalent to 11 psi down in the soil. You see this bulge or this compaction bulb that occurs down in it. Now you come in and you start plowing or tilling to get rid of it. You'll notice that the depth of the tillage reduces the bulk densities down. But then the tillage actually increases the amount of compaction just below it. And so you see this slight increase in bulk density actually below that tilled layer. So there's still a compaction layer down there, and it's just particularly underneath what you could till to. And that's from the down pressure that the tillage implements need to be able to break through that surface soil. And so when tillage compaction happens, well, to go into the next year, you've got to be able to level those ruts out, fill them in, create a nice smooth seed bed for yourself to then plant in that next year. And so oftentimes these ruts from a wet harvest or something like that, we smooth them over and move on. But that smoothing over doesn't mean that the consequences are necessarily gone. And so wheel traffic compaction has certainly changed over the years, particularly the wheel loads, the axle loads of equipment have dramatically increased ever since diesel engines started becoming really the technology of choice back in the 1950s, moving into the 1960s. And so if we look at front wheel loads, for example, on combine harvesters here, they've increased eightfold since the 1960s, much heavier than what they used to be over time. You look over here on tractors, whether without or with pulling an implement to it, they've gone up 5 times as much, or 3 times, pardon me, as much as what they were in the past. So equipment's gotten larger, axle loads and wheel loads have gone up. And as one might expect, you look over the same similar time period here, and we look at some metrics for soil depths, of which stress equals the level to where we can start expecting some compaction to occur in a lot of soils. You see that this increases, or the depth of the compaction risk increases with depth over time. And you'll notice that I put this little orange or red bar right here in the middle. This is at 20 centimeters. And getting an implement that goes deeper than 20 centimeters or 20 inches to be able to dig down even inline plows, paraplows, things like that, you're really not going to reach below 20 inches. And so our size of equipments have gotten over the years to where compaction is much deeper and therefore quite a bit different than what it was back in the day when equipment was only 10 tons or less for the entire piece of equipment that's out on the field. So compaction is deeper, it's more severe, and so it's different than what it was in previous generations. And this means that it tends to stick around for a while. So even though this data is from quite a while back, this is shown all throughout data throughout the world that you can see on high axle loads and compaction events. So in this case right here for relative corn yields, after a one-time 20-ton axle event that goes through, the next year yields were dropped by 30%. The second year afterwards are still down 11, 12% than what they were beforehand. And then it takes another 3, 4, 5 years before it gets back up to previous conditions. But something to also note is that even though it takes several years to see that yield decline recover, you'll see that in some years later on, you see quite a dramatic drop again compared to control plots. And these are due to the deep compaction that's still existing out there in the subsoil, those that you can't mechanically reach with an implement. And so on particularly wet years, you might see another 12, 13% drop in yields. On a very dry year, you might see 15% drop here. So over time, your yields are consistently decreased as you have these variable weather years with subsoil compaction that's still left in the field. And this is just another little diagram that kind of gives a little idea of the upper part of the subsoil will tend to recover over time, but then topsoils, they tend to recover quicker. So it's these deeper depths that take more time and have these longer consequences for your yields. And we can see this out in fields. So this is an aerial photo of wheel traffic compaction taken in western Minnesota by a good colleague of mine, Jody DeJong Hughes, that I've worked with for years on tillage and compaction. And you can see all the traffic out in this field. But I want you to kind of take maybe a closer look here, and you can see the planting direction in this field. You can also see old traffic lines that are cutting at an angle against the planting direction. You can also see older traffic scars that also emerge that are not from the current year that's out there. And so there's multiple years that you can see visible evidence that's impacting even the population counts and the growth stages of the crop when they're out in the field due to these high compaction. And you can see this just not only in Minnesota, you see it in North Dakota, you see it in Iowa, you see it in Ohio. There's many incidences where you can even look at NDVI from satellite imagery, and you can see these traffic patterns in the middle of the cropping season where the crops are showing the signatures of that compaction stress. And when this happens, basically the next year's crop yields, they're not going to be as high as you want, pretty much no matter what you do after that compaction event. Your yield components for grains are going to be shifted and changed. So this image over here on the right side is from a rutted area next to a control soil. Oops. Where here on the left side is the control soil. So you can see more variable ear lengths in there, and that impacts your yield components. And so in 2019, it was a very particularly wet year up where Jody and I were working at the time in North Dakota and Minnesota. It was a wet spring. Crops got delayed when they got in, and then we had an early wet fall. And so it was very tough conditions for a harvest. But these years, they happen. And it was one of those years that for even the folks who could get in before winter freeze up, you'd see ruts from one end of the field all the way down to the other every single pass of the combine. And so it was a high risk year, and a lot of acres had subsoil compaction from ruts. So we decided, well, can we project what could be the yield losses and economic cost to producers in these areas from this one particular wet harvest in North Dakota and Minnesota? And there's a lot of numbers on this sheet, but what I want you to focus on here is that there's multiple years worth of reduction that you can find throughout the literature on what type of crops and yield losses due to wheel traffic compaction. But what I want you to notice here is that if you're in the 50th percentile on one of these fields over the first 2 years, so you're better off than half the folks that had compaction. You're worse off than the other half of the folks who had compaction. You might expect around a 21% yield drop that next 2 years, over the next 2 years. If you're in the 25 percentile, so there's for every four neighbors that you have, three of them are worse off than you, then you might have a 15% yield drop. If you're on the 75 percentile severity end of it, then you might have a 35% drop in yields, and then it gets worse from there, even up to 50, 60%, depending on the extent of those wheel traffic compactions in the field. So you have these percentages. We took these and we projected across different portions of land grown into corn and soybean in North Dakota and Minnesota over the next 2 years for 2020 and 2021. So on these graphs, these are in millions of US dollars and economic costs directly to farmers. And then on the x-axis here, this 0.1, that's saying 10% of land. Let's say 1 out of 10 fields had wheel traffic compaction on them, or 10% of all the lands that were in corn had wheel traffic compaction, and then it goes up 20%, 30%, and we did that both for corn and soybean. But what you can see is that we're in the hundreds of millions of dollars pretty much any way that you split it. Even if you go with just 10% of the land got compacted out there, you're looking over $300 million in corn costs or cost on corn fields, which includes only the yield loss and the expenses to fill in the ruts. No additional externalities that go on to compound with supply chain logistics and everything like that. So this is kind of a basement minimum cost that's out there. But it gets expensive really quick, and it can stick around for even longer than those 2 years. So when this compaction happens, one of the first steps that I usually recommend to folks is to fill and smooth out the ruts, because you got to get another crop in there and you can't plant into 4, 6 inch deep ruts. You just can't do it. So fill and level the ruts just for the spring planting. Subsoil dries slower than topsoil, so unless you know it dries out quite a bit, avoid trying to go after mechanically going after the subsoil compaction. It's probably just not going to be a viable thing to go after that next year. Just note that subsoils, when they get compacted, they stay wet longer, and so one way to insult compaction is to smear over, have these smeared plains in compaction. So for ruts that are less than 4 inches, you might use your secondary tillage implements, whether that's a disc cultivator, vertical till, something like that. If they're below 4 inches, then you might get out the chisel plow and start filling them in, but aim for a little bit shallower than what the actual rut is and use multiple passes just to fill it in and smooth it out for that next planting to get a next set of roots into that crop as best as you can. Second step is adjust your practices to avoid adding new compaction. So that's going to involve adjusting lower tire pressures, adjusting them down to field rating. So we're down in 11, 12 PSI for tires, but you got to be careful because you can't drive fast on the roads at that pressure because of the sidewall stresses, and you got to be careful with the warranties on your tires there. But if you have a central inflation system or a VF system, then use that to your advantage. Also, if you have radial tires, dropping them down to the recommended field pressures is how you use that technology. If you got bias ply, when you buy radial tires, the technology versus the bias ply that's not as flexible on the sidewalls, if you're not dropping the tire pressures down, you're really not using the technology that you paid for. Minimizing actual loads really influences that depth of compaction. Try to cut out field passes if you can, or when you are out there, control your traffic by driving in spots where it's already been compacted or you've already been driving in, because compaction tends to, most of it occurs on the first pass. Avoid wet soils when you can, but you're going to need patience with this because sometimes we get into logistical jams when it's wet and crops have to get out of the field and tough choices are just innate to the situation. So ways to break up compaction here. I want to give a variety of different ways that are out there. The first one, biodrilling with roots. So crop species, root architectures, genetics matter in here. I like this diagram right here because it shows that when you have a soil that has a compacted layer down in it, roots start going and then they'll grow laterally once they hit it. But when you have something like a long-term no-till or something that's promoting biopores to be produced and persist, you're not mechanically disturbing them, you get these biopores that go through these dense areas. The dense area is still there, but the roots have gone through it and allowed the new systems to get down lower and explore and utilize the resources down in that soil, and that soil will better drain and have aeration as well for subsequent traffic operations that you need to do in your operation. But it's just not about making a root hole. It's also about what happens next to it over time. So if we take a CT scan of a soil here, you can see all the minerals in it. You see the roots highlighted in brown here. But all this purple area around it is area where that root likely has a very good chance of influencing that soil in the immediate area around it, the rhizosphere there. So you can imagine as this root elongates, it pushes that soil, and if you get roots into a new compacted area, the first bit of roots that go in, they'll actually drop the porosity right next to them because they are creating compaction right next to them. But as you get more and more root systems into it, that will be alleviated and the porosity will go up next to them and you won't have nearly as compacted soil. So you need cycles of root systems going in and a little bit of patience for that to happen. The reason why this happens, because like in this diagram, you have this root cap that's compacting the soil right around it. But as it elongates, it also creates shear stresses and can break up part of that compaction. You get root hairs that go in and exudates and hyphae from fungi that's then wrapping and creating these webs that have high friction in them and packaging these soil clumps together. Uh, this happens more and more the more root systems you get in there, and those roots will remold that compacted area into their own compacted preference for that soil to function. So some examples right here. I really like this study from a handful of years ago to where they grew a couple different types of cover crops here, tillage radish, vetch, and black oat. They had non-compacted zone up top, but then down at some depth, they compacted the soil. And after 20 days of growing these different cover crops, where we got dicot with taproot, dicot with fibrous roots, and monocot with fibrous roots, it looks like all these are doing quite well. They're going down. There's lateral roots on some of these systems being produced as you'd want and everything. But then when we jump forward to day 58, you can see the tillage radish got down to the compaction and then stopped growing the tuber there. But then fang roots started coming off of it and growing down into that compacted area. And you'll notice these fang roots, they don't have the lateral roots coming off of them. And that's probably from some of the struggling with the compaction around it. But in this case, the actual tillage radish isn't breaking up that compaction. It's almost serving more as a sensor for where is the depth of compaction that's there. The vetch struggled quite a bit, but the black oak kept going almost as if nothing was even there, had no problem with it. But you'll notice on the black oat, it doesn't have any of these lateral root systems to really explore out horizontally and help remold that soil too. So leveraging a couple different kinds of roots, structures, and mixtures can kind of help speed up or perhaps enhance some of the area that you're trying to remediate compaction by using cover crops. And here's a good example of a tillage radish to where it went down, and you can even see the fang roots right here. They go out laterally. They don't even went down into this compacted field. And so this is again is serving as a sensor, but you can go out and you can look at your cover crops and see how their roots are behaving and get a sense for what depths are the compaction an issue at and how severe it is based on how they're actually responding to the compaction as well. The next thing that I'll mention just very quickly is natural cracking of clays during the summer if you have the right mineralogy. If we look in a soil profile and we just zoom in, we can see different kinds of crystals, maybe just some crystals. We've got kaolinite clays. We've got these fabrics of more 2-to-1 finer clays. We zoom in and it looks kind of like torn tissue paper, but we keep zooming in and you'll see different mineral types and you can see the actual individual layers on them. So this is a transmission scanning electron microscope image here. And these illite mineralogies, they only have a millimeter or a nanometer spacing in between, but smectites, they have 1.3 nanometers. That little bit of difference means that these illites, they won't shrink and swell, but the smectites, they'll shrink and swell tremendously, that little bit of difference. And that can matter because when you compact the soil down and you have these anchor points in the soil and it's kind of this fabric of clays in between, they act almost kind of like scissor jacks, opening and shutting as you wet and dry. So as the soil starts drying that has these 2-to-1 clays that like a smectite in it, they'll start drying, but they'll get these deep cracks and then lateral cracks will start forming off to the sides from there. And you can see this in some places. So up in North Dakota and the Red River Valley is quite particular on smectite concentrations in its clay fraction. And even on areas where this is a construction site next to Fargo, you see the sharpshooter shovel here. The original ground level is maybe 2, 3 feet above the top of the handle. And all these dark areas down on the ground, those aren't shadows from a tree off to the side. That's topsoil that's sloughed off into cracks that had opened up during drying events. So these cracks can go very deep and break up deep compaction even beyond what you mechanically can reach. And here's just another example just over the border in Canada, there in the Red River Valley too, to where a surface drain exposed, you can see all these deep cracks where topsoil had sloughed off in them. But when compaction happens, it's wet, and so those clays are tend to be hydrated. And due to the speed that you drive over, even though it's compacting down, it's not you're not sitting out there long enough for all the water to be squeezed out of those clays and for them to fully collapse. So even during a rut, there's plenty of room for that soil to still dry. And if it has the right mineralogy, it's going to crack and get those deep compaction broken up for you. So if you go out and you till, just be in mind that you could be disturbing some of that cracking and weakening that soil again. So you're kind of fighting against nature that's playing on your side in the first place. Freeze thaw, just very quick on that. Freeze thaw is usually the question I get asked the most in the past is, doesn't that alleviate my compaction? For surface soils, sure, absolutely. Even up in like Grand Forks where it gets very cold and you have a lot of freeze thaw cycles during the winter, most of that freeze thaw cycles is consolidated up into the just top depths where your typical primary tillage implement like a chisel plow is hitting in the first place. But that deeper compaction, that depth, it might freeze once and thaw once over the course of a winter, even up that far north. And so that you need multiple freeze thaw cycles to be able to alleviate the compaction. If it takes 2 dozen freeze thaw cycles to break up surface compaction, then it's going to take decades to break up subsoil compaction, relying on winter freeze thaw. So it's just not really a viable option for when you're talking about wheel traffic compaction. And then the last thing I'll mention here is subsoiling and paraplows. So poor odds of working and little gain when it does. I'll show this real quick. This is a nice meta-analysis global review of over 1,500 paired sites across the world, looking at deep tillage into compacted areas. And this right here, this graph shows deep compaction versus the yield off of the control. So a value of 1 means no gain whatsoever. 1.5 means 50% higher yields than if you hadn't have done it. And then the same going the other direction here. So usually this is really nice. People will think it's like, oh, I got all this blue area, tons of space to be able to increase my yields 50%. Well, there's context to this, and I want to give an example here because the mean is actually down here right where this bar is. And this whole white area, that's the middle 50th percentile in the area. So I want to give some context. If we go back to those yield decreases, those yield reductions that we calculated earlier, and 15, 21, and 35%, depending on where you were at in severity compared to your neighbors who also got compaction. If we just said that, well, let's run a scenario. Let's say that we were going to get 200 bushels per acre corn yield off these fields, but then we apply these different severity cases. So 21% loss in yields would go down to 158 bushels per acre. And you see the other two on how severe those would drop a 200 bushel expectation down as well. Now, if we take the global mean of improvement from deep tillage based off of this global survey right here of just 4%, only 4% gains back, and then say, okay, let's take those yield losses, apply a 4% gain for it, you get now 164 bushels per acre when you're right in the middle of severity. You get a little bit there, but it's nothing to write home about, and probably doesn't pay for all the diesel and time that it took to pull that implement across the ground too. So what do we really need to reach the full alleviation effects of these? We need to be in this really 18 to 54% gains. We need to be in the top 25 percentile of deep tillage performance. And everyone likes to think that they're in that percentile, but for every four folks, three of them are going to be disappointed. And so when does this top 25 percentile occur? It's when a root limiting layer was there. If you've been in something like a long-term no-till system or something like that, you probably don't have compaction issues down deep. It's probably something else. So check and make sure that you actually have a compaction area using penetrometers or some other means to check and make sure it is actually there before you go in and start deep ripping. Soils that lack significant quantities of silt, if you have a silt loam soil, they don't tend to tolerate deep ripping whatsoever. It's better just leave the implement in the fence line. Um, Topsoil fertility tended to be poor, and then there was a significant drought occurred. So this is quite a combination to be in this top 25% performance for deep ripping for it to actually work, to give a little context for that. And this is just graphical representation of the same thing that I just showed. And so to wrap up here, real quick, some summary and suggestions. I just want folks to remember that compaction sticks around for multiple years. It stays around. It's not a one-year issue. When it does happen and you have these ruts in the field, fill in those ruts. And then use practices to protect from new compaction afterwards and use the strategies to alleviate the current compaction that you have at your hand. So that's when you get to know your field and how it responds. If you see cracks out during dry summers and stuff like that, that's actually going to play into your hand. Not that we want a drought necessarily to ever happen, but when it does, it can be used as a way of naturally alleviating some of that deep compaction that's out there. But keep loads light. Axle loads is what pushes compaction deep. It's not just the tire pressures. Adjusting tire pressures will influence just the top little bit of compaction that occurs in the topsoil, but axle loads and wheel loads is what pushes compaction deep down. And so if you have a 40-ton per axle grain cart, fill it halfway full when you're using it, especially when the field tends to be wet out there, because those high axle loads is what pushes this compaction deep. And then fewer passes as well out there. Getting new root systems and a diversity of root architectures and giving it that few years to help them get in, create the compaction they want, and then remold that soil. It's going to take a few years for that to happen. And then leveraging the crop diversity that you may have, some shorter season varieties or planting small grains if you have those markets around you, leveraging some of these options that you have to be able to get as many root systems into the system as you can for it. And just for last couple things here, some resources. So Jody DeJong Hughes and I, we've put out a couple guides in the last few years, and there's links here to where you can download them for free. They're 30 to 40 pages long. They got a lot of great content in them, but the one here particularly is the Upper Midwest Soil Compaction Guide that you might check out. And then usually when people start talking about compaction, they also want to know something about tillage. So I put our tillage guide in there too. And these website links are pretty much the same thing, same link. It's just the last number. The compaction one ends with a one, the tillage one ends with a two. So it's easy to take a look at both of them. And with that, I'm happy to answer any questions. And anyone who's watching this webinar live now or watching the recording in the future, always feel free to reach out to me at my email here. I'm happy to at least point you in the right direction or get you in contact with the right folks for your questions, and I'll help address anything that I can too. Because we could talk for days and days and days about this topic, but we only had a few minutes here. So thank you much.
Okay, here we go. Um, let me get up to the top. Sorry. Somebody asked about annual ryegrass, what it might do for compact, what its maybe root structure might be like, if you know anything about that.
Yeah, the annual ryegrass, it has a nice fibrous system into it, and when you have a good spring that occurs, you can get some really good growth out of it, and good coverage with it. One of the hard things is always getting good coverage with anything. So I would almost say, it's kind of the way that whether it's rye or something else, it's the way that you're able to get in and apply it and get it down. If you can get it in good contact with the soil and it works into your rotation to where, up in some parts of North Dakota, Minnesota, where I used to live at, you've got wheat in the rotation. So on your wheat cycles, you can get the wheat out and then you can get the rye in and you're able to drill it in perhaps. On other years where you might be broadcasting aerially or something like that, you might have these spots where it doesn't grow as good, but it's more about the timing or something, or when leaf drop happened, if you're going into soybean or something like that. So, but it's a good crop because it has those fibrous roots that tend to like to get down deep for it. And so I like it for that regard. Again, like any of these other cover crops, it's going to take a couple cycles of those to really hit their full capacity.
Okay, kind of associated with it. If you had, what would be your recommendations for a cover crop mix for compacted soils?
Oh, that's a good question there. That is an excellent question and a difficult question because when you think about what's best, well, there's a cost requirement in there too. Some of these mixtures are quite expensive, or they have been in the past, and whether or not they're available. Usually, when compaction comes around and people start buying cover crops, the seed supplies in your local area might decrease pretty quick because they get bought up. I've seen that happen before there. So I think one of the things is I like the idea of having a couple different root systems in there. You don't, do you need 50 different types of species? Probably not at all. But if you get a couple in there, that's great. Even if it's not available and you have something that's just a single species, but it's cheap and you can get it in and you can get roots start going that next year, it's better than not having anything that goes into it. So I think it goes with the supply that's around you, the costs that you have locally, and where you're at in your rotation just to get in what you can to get it started.
Okay. There's a couple people that were asking about alfalfa tap roots over a couple years and how those might compare versus some of the cover crops you talked about.
Yeah, that's a good question too, and I don't readily have an answer for that one. Just because I haven't seen data explicitly on alfalfa and compaction. I imagine someone has data out there somewhere on it, and it's just probably locating it. But
Okay.
with alfalfa, since it has multiple years that are out there, if you have roots that are in place, then when the conditions get right the next year, then lateral root systems and more root elongation, it can just perhaps get off to a quicker start than starting purely by seed. So I can see
Okay.
the benefit of it and how it has a pathway to be influential there. Um, uh, yeah.
Okay. Kind of a couple related questions, I think, here, but how does soil moisture content play into the freeze and thaw cycles for alleviating compaction? And kind of, we've had a number of years where our soil moisture has been pretty dry in some areas, and then, maybe wet, hopefully sometime in the future. But
Yeah, yeah. I really like that question. That's actually something I throw at my students in my soil physics classes there is exactly that. So one of the things to think about is during the winter you have energy being exchanged. And so when you move water into either vapor or you put it into ice, you're exchanging energy here. And there's only so much that you can exchange over the entire winter that's there. And so think about the amount of water. If you have a lot of water, let's say your ground is just soaking wet when it goes into freeze, into the winter freeze, it's going to sh freeze to a shallower depth because there's it's going to freeze a certain amount of water.
mm,
And so it doesn't have to go deep. If you have a pretty dry soil when you go in, that frost front will go deep down into the ground. It'll go quite a bit deep. That's when you see areas where it's like, well, we were busting water pipes down 9 feet deep. That soil was probably pretty dry around it, but then you got down to where water was, and that's where it expanded and had issues with it. So think of it as same amount of water tends to get frozen over the year. It's just do you have an ample amount that's already there so it doesn't have to go very deep to freeze that amount of water?
great. I hope you're speaking of Fargo when you say 9 feet deep, because that you
Yes.
probably heard about it when you were up there. And
Yep, yep. That
maybe
was
not
either
quite
my
that, maybe not quite that deep here, although we've definitely frozen water lines. I've not heard of one 9 foot deep though, but
yep.
that
My first or second winter up there, we had some 9 foot deep pipes
okay.
burst.
Oh man. Okay. Um, they we've somebody's asking a question that they'd heard that Australia has had success with tram lines and traffic control in addressing soil compaction. They indicated they know NRCS has a practice. Can you speak to your experience with tram lines and controlled traffic?
Yeah, so on tram lines, when you're instead of pulling an implement that's full of something out there, so like when you're putting down slurries or something like that, I mean you have less load that's going on to the back of your tractor, so your axle loads are going to be should be not as high as they would be otherwise. Now, if the ground is pretty dry out there, it's probably not going to make a big difference. But if it's kind of medium to a little bit wetter conditions, then that's when you're going to really see the benefit of that because you just don't have that extra axle load addition that's out there. Now, for controlled traffic, the difficulty with controlled traffic is, well, there's lots of implements, there's many different tire combinations. Getting a pattern and a consistency across all your implements tends to be challenging with it. But you do have repeated traffic that happens in a field. So like when you're still going out, well, the classic easy one is just the headlands where you have semis being pulled out there and you keep it consolidated to those headlands. You don't pull semis out onto the actual field. You bring grain carts back over to the semi and then offload there. That's something that I've seen a number of places in Australia be quite adamant about is that they keep their heaviest loads and they keep anything with truck tires on them on the headlands. And oftentimes they don't even plant into those headlands. It's just permanently in grass and dedicated for that loading, offloading, high axle loads in that area. So, it's another thing too that's an interesting is to think forward in years ahead on what can happen with equipment and their sizes. Things have progressively gotten bigger and bigger and bigger. I mean, you're up 2,500 bushels grain carts in some areas that are being sold now. And so tremendously big equipment. Combines have gone up in size, but there is this thought that things could get smaller in size as autonomous vehicles come around. And so I've seen some really neat data and some interesting conversations with Scott Shear over at Ohio State University on some of the equipment and manufacturing side of field operations on will things actually start getting smaller because you can use them in an autonomous fashion. And so instead of having one big piece of equipment, maybe you have nine of them. And so they're smaller axle loads,
Mm.
and your concern about compaction starts to dissolve at that point. Now that's all based on what the industry ends up going towards in the future years, but it'll be exciting to see how it goes and how we can start perhaps doing controlled traffic differently in the future.
Okay, great. Some companies promote gypsum or even lime applications to relieve compaction. I guess, have you done any work on that, whether that has any positive impact on reducing some of the compaction?
Yeah, so I have not done any research on that. I have seen those thoughts in the
Okay.
past, and I've never seen data that actually shows that it'll make much of a difference.
Okay.
From my understanding, it kind of goes into, I mean, when I was growing up, it was always like if you had a problem with something, put lime down. That was a go-to kind of first. If you don't know what it is, put lime down. Well, if you there's many situations where that's actually goes against what you want to do there. If you have phosphorus deficiencies and issues there, then putting down lime's not a great idea for fertility standpoint. But gypsum is often thought of as helping alleviate sodic soils, soils that have a lot of sodium in it. And the compaction, the internal self-compaction that sodium soils cause by clay dispersion. That is very different than equipment-induced compaction. So if you don't have a compaction if you don't have a sodic soil problem, it's hard for me to envision a pathway of how gypsum will be a remediation tool for equipment-induced compaction.
Okay. Um, Somebody is asking, are there standards for penetrometer checking and any studies that have documented mitigation of compaction using a penetrometer? And then somebody asked if a Troxler or nuclear soil density gauge would be valuable for quantifying compaction. So somewhat related, I guess.
Yeah, yeah. It's measuring, is it there?
Yeah,
Which
right,
was one of
right,
the
right.
things
Yeah,
yeah, it was one of the things I mentioned where it's like, make sure that is your problem before
yeah.
you put in the time, energy to, start pulling a disc ripper across the field or something. So for a penetrometer, there's thoughts and metrics on at what point do roots start struggling. Oftentimes 200 psi, you start seeing this like people say, oh, now that's when it's really severe and compacted and there's an issue to be there. What I would encourage people to look at is just not only the value, but the shape of the strength of that soil as you go deeper. If you have something like in one of the earlier graphs that I showed where you have this clear kind of bulb or bulge up top that goes down 8, 10 inches, then that's probably clearly equipment induced compaction. And so you can be targeted about using that information now with when do you go out on the field? Do you lower the axle loads with how by unloading more often or something like that. You can start making choices based off that. You can also, when you go out and you use a penetrometer, instead of just going in one spot or randomly in spots, go based on strategically what you see in the field. If you see, I've had ruts here and I want to know how deep that's gone, measure 2 rows outside of it, go into the rut, go in between the tires, and then back across it again and see, when you compare where you didn't drive versus where you did drive, you get a sense of the severity of what occurred. And now you've got more reliable information to make an action off of. So that's what I recommend for penetrometers and using that. Bear in mind that the moisture content differs quite a bit. If you go out there in the middle of summer and it's like concrete out in the field, it's going to look like nothing should grow there in the first place if you take a measurement. So, wait for a good rainfall event, go out there 3, 4 days afterwards, and then take a measurement, and you get a better, reliable feel for the measurements for the using the nuclear devices for measuring density. I haven't really seen that used as much in agricultural
Yeah.
practices and stuff. I've seen them used in oil pads and in coal mining and stuff, and some of that kind of work that I've done in the western part of North Dakota when I used to live up there. Um, It's a nice tool for things. No one likes to deal with radiation if you don't have to for it, and you get a measure of bulk density. Now, when you want to do a lot of area and something that's pretty quick, I'd say the penetrometer has its advantages over that more expensive nuclear device with it, but it is used more in industrial situations, more from a civil engineering standpoint.
Yep, that reminded me of, yeah. I used some when I was back in my civil engineering days. It's still quicker than a sand cone method for
Well, that's true.
determining bulk density. So you want to take some time. That's it.
That is
Okay.
true.
Somebody asked that they spread compost from hogs. Is there a cover crop that you think could help with getting the nutrients into the ground other than having to do tillage?
Ooh. Huh. This one's outside of my
Yeah.
my wheelhouse here. I'd say
Yeah.
almost like Daniel Anderson in your
Yeah.
department there.
There we
That might
okay.
be him or Amy Schmidt over here at in Lincoln, Nebraska might be good for those questions on getting manure down. You know, when you create biopores, it gives opportunities for next rainfall events to move material down into those biopores. You also give when Nesic earthworms come up and grab materials, if they grab leafy material and pull it in, it can pull manure down in too.
Yeah.
You know, one of the things I remember hearing a lot of people ask about, whether it was with manure compost or synthetic fertilizers, is when I have a reduced tillage system, does the stratification of phosphorus, how do I deal with that? And, from a number of good soil fertility colleagues of mine, I always hear them ask, it's like, well, is it really a problem? Do you see phosphorus deficiencies? Even if you test and you look for phosphorus in leaf tissues and stuff, do you see the deficiency there? And most of the time, people say no or they don't know.
Hmm.
So the stratification, I think it perhaps could be a bigger concern than there is really the frequency of it having a consequence.
Yeah. Yeah, and actually, we found with a little bit of with some work that at our Gilmore City site, where we went with no-till and cover crops, we reduced some of the stratification compared to just no-till.
Okay.
So that cover crops, just like you talked about, might be helping us, with either earthworms or biopores there to move a little bit of that phosphorus, so it's not just at the soil surface. So, um, with that, I think in the interest of time, we've taken a lot of Aaron's time today. Thank you so much, Aaron, for a really important and useful talk. Please consider tuning in for the last couple of the Midwest Cover Crops Council webinars the next couple days, and then tune in next week for talking about nematodes as well with the Iowa Learning Farms webinar. With that, I'll give Aaron any last parting comments.
Yeah, well, thank you for having me. I really appreciate it. It's compaction, like I said, is one of those topics we could talk for days and days and days about. Again, anyone who wants to reach out, feel free to do so, whether it's on this topic or a number of other topics that I've worked with in the past. This is one of many interesting things that I've had the fortune of being able to do some work on. So,
Okay. All right. Thanks, Aaron. Great to see you as always.
yeah, great to see you. Thank you.